Hi, welcome to my video on word problems part 4, and this is extra number 2, so some extra word problems to help you understand word problems more. A person's height in meters on a Ferris wheel is represented by the T of H equals negative 12 cos pi over 10 times T plus 13 at a certain height at a certain time T in seconds. So H is height and T is time. It says find each in relation to this equation. So what we have this equation. So we have A to be negative 12. We have B to be pi over 10. And we have K to be 13. So that's the equation. There's A, B, and K. Notice there's no bracket here, so that means that H is equal to 0. So it says find a height at 0 seconds. So 0 seconds, the time is 0. So the H of 0 equals negative 12 cos pi over 10. T is 0. So we're subbing in 0. And 0 times pi over 10 is 0. And negative 12, the cos of 0 is 1. So that gives us a negative 12 plus 13, because we have to multiply before we add in PEMDAS. And so we get a 1. So the height is, and it's in meters, so the height is 1 meter. Find a height at 45 seconds, so that means time is 45 seconds, so we'll sub in 45 in the place of T. 12 cos pi over 10, 45 plus 13. So that gives us negative 12 cos, and 45 over 10. 5 into 10 goes 2, 5 into 45 goes 9. So that's 9 pi over 2 plus 13. So 9 pi over 2, let's look at 9 pi over 2. 9 pi over 2 is, notice that 2 pi is all the way around, so if I take off 2 pi, that gives me 9 pi over 2 minus 4 pi over 2. We got 5 pi over 2. Again, 5 pi over 2 is more than one revolution, so we'll take off another 2 pi. So 5 pi over 2 minus 4 pi over 2 gives us pi over 2. So 9 pi over 2 rotating around a circle is the same as 90. So 9 pi over 2 is the same as pi over 2 because it ends up in the same point on the circle. And the cos of 90 degrees, cos of 90 is 0. So negative 12 times 0 is 0, plus 13 gives us 13. So at 45 seconds, the height is 13 meters. Now ask, what's the radius? Well, the radius is the amplitude. Because the amplitude is what keeps changing up, same as the radius. As the circle rotates, the radius, it moves up the radius and up and down the radius. So the amplitude and the radius is the A, and so it's the absolute value of A. So A is negative 12. So the amplitude of the radius of the circle is 12. And the height of the axle, well, that's the same as the sinusoidal axis. And the sinusoidal axis is the K, and the K is 13. So the height of the axis is 13 meters. And the radius is 12 meters, which is 12. And the period involves the b. So we know that b is pi over 10. b is pi over 10. So the period is 2 pi divided by b. So that's 2 pi divided by pi over 10. So that's the same as 2 pi times 10 over pi, because we got to do the reciprocal of the denominator. Pi's cancel, and I get 20. So the period is in terms of time, so it's 20 seconds. Now, the speed of the wheel is the rate or how fast the wheel is traveling. And so the speed is I'm going to put R, I'm going to write down rate, is the distance divided by time. And the distance around our wheel is the circumference. So the circumference is 2 pi times R, which is the radius, is 2 pi. And the radius is 12. And it's in meters. Make that meters. So that's 24 pi meters. So the distance is 24 pi meters, and the time to go around is, let's see, what is the time? The time is, we picked up the period as the time, which is 20, and I put S for seconds, and so we work that out. 4 into 24 goes 6 pi, 4 into 20 goes 5, so the speed or the rate is 6 pi over 5 meters per second, because the speed of the wheel is the distance, which is the circumference divided by the time, and the time is the period. And next question, how many times in the first minute will the height of the person be 13 meters? So let's draw a little diagram here. And this is the ground. And we got a Ferris wheel, and we know at 0 seconds the Ferris wheel is 1 off the ground. So the Ferris wheel, let's say, is this. This is 1 right here off the ground. And the sinusoidal right here is, the radius is 12 here, and the radius here is 12. So notice 12 plus 1 is 13, which is your sinusoidal axis. So what happens at 0, the height is 1, but the period is 20. So the increment changes is P divided by 4. So 20 divided by 4 is 5. So if you're right here at 0, you're right here, this is 13, and this is 25. This is 1 plus 12 plus 12. Right here, you're at 13, because it's 12 and 1, and right here you're back to 1. So what happens when you start at 0 and you add 5 on, then you add 5. This is adding on time. So watch what happens. When you're at 0 right here, 0 is a 1. At 5 seconds, you're at 13. At 10 seconds, you're at 25. At 15 seconds, so you're at 1, and you're at 13. 10 seconds, you're at 25. 15 seconds, you're back to 13. And 20 seconds, you're back to 1. And this keeps on going. So we go 25 seconds, 30 seconds, 35, 40, 45, 50, 55, and you're at 60. So this keeps this pattern. So 25 is 20, you're at 1. So now you're back to 13, 25, 13, 1, 13, 25, 13, 1. So how many times? So you're at 1, 2, 3, 4, 5, 6. 6 times your height in the first minute, 60 seconds. 6 times your height, you will be at a height of 13. So a little different question. Now we have another one pertaining to the Ferris wheel, but the wording this time is a little bit different. A Ferris wheel with a radius of 8 feet is 4 feet off the ground. If it rotates at a constant speed of 3 pi feet per second, find the equation representing the height as a function of time from its maximum height. So we have a radius, which we're going to call r, and it's 18 feet, and it's 4 feet off the ground. Just writing down the information. And we got a speed or rate of 3 pi feet per second. And we want to find what we want to find as a function. So we want to find a height as a function of time. So let's have a look. Let's draw a picture of what we have here. Let's draw a picture. Sometimes we have the ground, and the Ferris wheel is 4 feet off the ground. So let's put 4 feet off the ground, and let's put the center here. And it's not drawn exactly to specs, as just doing an estimation. And it says 4 feet off the ground, and the radius is 18. So this is 18 right here, and it's 18 right here. So the Ferris wheel is spinning at a rate. So what happens? Let's go and find, we have this distance. So let's go and find the sinusoidal axis, or the center, the sinusoidal axis is the the height of the axle. Spell that right, height of the axle, and that's the K. So the height of the axle, one way to do the height of the axle, 4 off the ground with 18. So the height of the axle is right here, 18 and 4. So K is 22 if you do it that way. Another way to find it is that if it's 4, 18, and 18, that means the maximum distance, maximum height is 40. The minimum height, h for height now, don't get confused with the h for in the equation. The minimum height is 4, so the average is the sinusoidal axis is 40 plus 4 divided by 2. So that's 44 divided by 2, 22. So K is 22. Either way, you can draw your diagram and say 4 plus 18 is 22, which is the sinusoidal axis, which is the axle, or it's working out the difference between the maximum and the minimum height divided by 2, or the average, what's in the middle. Okay, now we have, let's get the amplitude. You get the amplitude is the radius. When I think about a Ferris wheel and amplitude, the radius is what keeps changing as time goes by. And the amplitude is the A. So in this case, we have the A is the maximum distance height is 40 minus the sinusoidal axis. So A is 18. So the amplitude is the radius, 18. And now we said that the H was 0, because if we start off at its maximum height right here, then notice if you think about on the XY axis, that's time is, or the height, the time is 0 here. So H is 0. Now we have to go and see if we can find, we have K, we have H, we have A, we got to get the B. So let's see, the B is, the period is equal to 2 pi over B. So how do we get B? We have a period, but we don't have the period. So we have to get, let's see, so we need B, so we need distance, we need the time. Let's see, here we go. What about if we do the time is distance divided by the rate, and the distance is 2 pi r divided, gotta be careful here, that's rate, that's radius. So we have 2 pi, radius is 18 meters, and the rate is 3, make that a pi, better be careful, 3 pi feet per second. So that's 36 pi meters divided by 3. Again, I'm going to do a 3 pi feet per second. So that's a 12. And notice we have meters, and we're going to multiply by seconds. Oh, meter, I said meters. I'm using meters here all the time. So it's not meters, it's feet. Sorry about that. I'm not careful enough. Trying to explain it, but not. And we got seconds divided by feet, so the feet cancels. So that's 12 seconds. So your period, your time is that, so your period is 12 seconds. So it's 12 seconds equals 2 pi over B. Cross multiply, we get 12B equals 2 pi. So B is 2 pi divided by 12. So B is pi over 6. Again, notice I said extra problems, so I'm trying to develop your thinking. So the equation is in terms of, because we're coming from the max, because we're going from a max, we have a cos, and because there's a max coming down, or coming down this way, it's counterclockwise, coming down this way, it's going to be a positive. So A is a positive 18. So the equation, y equals A cos B time minus H plus K. So A is 18 cos, B is pi over 6, H is 0, and K is 22. So simplify that. Oh, I got a Y here. So used to writing a Y is the H of T. Sorry about that. It's height in terms of time, because I want it as a function, not the Y. Yes, Y equals that, could be, but we want it as a function of time. So it's 18 cos T minus 0 is T, so pi over 6 times T plus 22. So that's the equation. Again, the question is different to develop your thinking, and you have to understand what's happening with word problems to make sure you can find. So sometimes you're given the equation, sometimes you got to find the equation that represents the sinusoidal motion. So that brings us to the end of working out these two problems. And again, if you like my video, click the like button. If you're not a subscriber, click the subscribe button. If you want to subscribe to my website, visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.